Right, so we're looking at this bad boy. So what? Remember, when we're doing these kinds of things, we're trying to look at this and establish which do we think is the bit that we're going to be replacing with our u.
I think it should be the number.
Nice, Mally.
Nice.
Okay. So, are we happy that we've got a fraction going on here? Notice that the whole denominator is not to a power, so this isn't one that we're going to rearrange like that. And so it's likely that we're going to be involving ln here because we've got something on the denominator. It would be nice also if you could kind of look at the denominator, think, right, we know we differentiate stuff that's different. What's the derivative of the bottom? It's 12x cubed minus 3x squared. Oh, look, that's what we've got on the top. So the fact that you can try and recognize that will also help you decide what you're substituting, okay? Is it chilly?
Yes.
No.
No.
Take your
Everybody jumpers, and then, I mean, I'm surprised that Alex didn't come with a scarf and a hat today.
Oh, she did.
Okay, so D. So I'm going to let you, it's pretty funny, you, the letter U, not Y-O-U, you be, oh, sugar popsicles.
What's going on?
I'll let you be that. And then what do we do?
The UDX.
Nice. The UDX,
Which is the top part.
which is 12x cubed minus 3x squared.
And then you have to do that there. It's like different.
Yeah, so
Right
should we, so I'm going to kind of split this now so before I do anything, I'm going to split this to say this.
Yeah, what the...
Okay, so all I've done is split them into like the fraction and the numerator. Because all I've done here is so that when we replace stuff, it looks normal. Is that not, do you know what I mean?
What's that?
Because this has obviously got a secret denominator of 1. And so we can always do that if we have a fraction. We can separate those two if it's easier for us.
Okay.
So then our question is now going to become integral of 1 over u, because that was our u. And then this was our du dx. This is our dx. So these, check you later. So we're just integrating 1 over u with respect to u. And so that gives us, oops, not u at all. Gives us ln u. What? No, this would be a plus c. But then obviously we're replacing this bad boy, so that's ln of 3x to the 4 minus x cubed. Plus c.
Oh yes, yes.
Yeah? Are we happy with that? What's the next page? Oh, we talked about this already. Why is this here?
Can we go back to the side?
Sure, sorry, I got excited.
I maybe think some practices from you. Because it's like on the tip of the finger, but it has to actually cross the
Roger that. Okay, so do you want us? I mean, I don't really know if I've got this again. We've already done these. Oh, sorry, Katie. How do you know
it's
now?
fine, yeah. Thanks.
It's twice. Right. Okay. So integrals of sine and cos. We know sine goes to negative cos. Cos goes to sine, and they are in the formula booklet, so you don't have to stress about those. Same principle though, that if it's sine of something, fancy pants, then it's going to be the cos of the fancy pants divided by the derivative of what's inside the bracket. They just happen to have put it as a 1 over a rather than all divided by a. Yes, because a is a derivative of that. Should we just do these now while we're going for the class? Otherwise we are going to be done with this and we may as well just make the most of it. Get our notes.
Miss Harrison?
Yeah.
Oh.
Okay, it's because it's a small sheet. I know. Well, maybe you want to write some of them at the top. I'm sorry.
I'm gonna get you afterward for Christmas.
Oh, it's cha-ching. I think you may not love me quite that much.
I know how to love things.
We're being videoed. So when a smart book is missing from Gateway, they come and find you. Alright, so do the numbers in the front have any effect when we integrate or differentiate? No, but they stay there, okay? So the integral of sine is,
Cos.
careful, the
Minus.
integral of sine is minus cos, yes? Okay, it's up there on the top, just have a look. So the integral of 3 sine x is going to be negative 3 cos x plus c. Yeah? Okay, B.
No, because this.
So now we've got cos of something fancy pants, alright? So cos integrates to
Son.
sine. Okay, to the top. So that's going to be sine of fancy pants, so 4x minus 6. But we're then going to divide by the derivative of the fancy pants,
So
which
4.
is 4. If you want to write 1/4, exactly the same thing, okay? Obviously plus 6. Obs. I think that's obs.
So this is going to be.
So C. Alright, so this is one of those, we've got a few things going on here. So do we want to use substitution or do we want to pretend?
Oh, so we actually use it as a chart.
Not quite, because we've got an e to the x and a sine e to the x.
Yeah, but the e to the x doesn't matter because it doesn't do nothing. So all you do is just stick it in the front and it becomes more.
Right, that would be if it was a 5, a 10, 11, a 1.2, whatever. But this has the variable in it, so it wouldn't be quite the same, okay? But, so this is where we're kind of like, let's pretend that that's not there, yes? Should we do the pretending method rather than, or you want to do substitution? Alright, okay. Alright, we can do both.
Whatever.
No. Whatever floats your boat.
Can we
majority rule, so.
can we do both?
We can do both. I can do both. So you can listen to both and write whichever one down you want. Well, you're going to get the same answer no matter what. Alright, so if we do, let's do the pretending first. So we're going to pretend that the e to the x isn't there. We're going to integrate sine of e to the x. What's the integral of sine e to the x?
Cos.
Careful.
Minus.
Cos e to the x. Now, but that e to the x was there, okay? But what do we do when we've got something different? We then have to divide by the derivative of what's different, yes? So what's the derivative of e to the x?
Yeah.
E to the x.
That's it.
And then what happens? We can cross those out, yes? So it's going to end up as negative cos e to the x plus c. We all happy with that?
That's what I said before, Miss Harrison. That was the one.
Well, that was the pretending method. Shall I do the substitution method now?
Sure.
So, substitution, sub method. So we're going to let u be e to the x, yes? So then du dx is e to the x. So then I've got the integral of, let me change the order. So sine e to the x dx is our original question. So that's now going to become sine u du dx. So that's going to be negative cos u, and that's negative cos e to the x plus c. Okay? Pardon? It does. But I just want, like, it's another confirmation that that's why the pretending works. Okay, some people will forget about when they see the e to the x, they forget about it altogether or leave it out. So you've got to be careful. It's still involved in the question. You've got to do something with it, but it doesn't affect the final answer. Okay, D. So this is another one where we could use substitution or pretending. Okay, are we happy with just the pretending, or do we want to do substitution as well?
Pretending.
Just the pretending. Okay. So, are we happy that we're going to have pretend that this is not there? So we've got D. I'm going to keep looking over your choice. So we've got x cubed. Pretending it's not there. And so what's the integral of cos? Sine. So we're going to have sine of 3x to the 4. Is it? Yes. We're going to divide by the derivative of what's fancy pants. So that's 12x cubed.
Can you cross off the
Yeah, so here we can only cross out the x cubed, so the 12 is still there. So then our final answer is sine 3x to the 4 over 12 plus c. Or 1/12 sine 3x.
Maybe I have this in front of me.
Okay.
Yeah.
Next page I think is in the wrong location because we haven't talked about stuff like this yet. So forget that. We'll come back to that later. Okay, so I think we need some good practicing.
I don't think so.